been spending a lot of time talking about functions, so now we're going to talk about how they're applicable in business and economics. We'll start off with some definitions, first being the cost function. The cost function is how much you spend total to make your product. This is made up of two components. You have your variable cost plus your fixed cost. Your fixed cost, these are the things that you have to spend money on no matter what. Whether you make 1 unit of your product or 1,000 units of your product, you still have to pay this every month or every year. This includes your rent, maybe the rent for the equipment or the rent for the building of your warehouse, your salaries, the utilities, electric bill, water bill, things like that. Then you have your variable cost. This is directly related to how many units you make. This is your labor, your materials, things like that. So if you're only going to make 1 scarf, then you need very little material. If you're going to make 1,000 scarves, you're going to need a lot more material. Now your revenue, this is the amount of money you make from selling your product. When you go out and you sell your scarves or whatever it is you're selling, however many you sell times how much you sell them for. So your revenue is your price times quantity. So the equation R of X equals P for price times X for quantity. Now your profit, this is the amount of money that you walk away when it's all said and done. After you've paid the money to create your product, then you earn the money from selling your product. Anything that's left over, once you take into consideration cost, that's your profit. So you find your profit by taking your entire revenue equation and subtracting off your entire cost function. So let's do an example. So we have Extreme Protection Incorporated, and they make helmets for skiing and snowboarding. The fixed cost for 1 model of helmet is $6,600 per month. That means whether they make 1 helmet or 1,000,000 helmets, they have to spend $6,600 every month. The materials and labor for each helmet that they make is about $35. Then the company turns around and sells each helmet for $60. So for this particular model, let's write the function for the cost, the revenue, and the profit. So remember your cost function. This is your variable cost, how much it costs for each unit, 35 times how many units are you going to make? We don't know, we call that X, plus your fixed cost, what you have to spend every month no matter what, $6,600. That's how we get our cost function is 35 plus X plus 6,600. Now your revenue is price times quantity. How much are we selling them for? $60. How many are we selling? We don't know, so we can represent that with X. And now your profit function takes your entire revenue function and subtracts off your entire cost function. What's really important to remember? You're subtracting off that entire cost function. So keep your cost function in parentheses so that you remember to distribute that negative. And when you do, you get 60x minus 35x minus 6,600. Always simplify your profit function. Always simplify. Combine like terms, we get 25x minus 6,600. Here's another definition, the break-even point. This is the point where you don't make any money, but you don't lose any money. What does that mean? That means that the exact amount of money that you spent making your product is the exact amount of money you made from selling your product. So one way of finding it is when your revenue is equal to your cost. The amount of money you made from selling completely balances the amount of money that you spent making it. Well, what does it mean if your revenue equals your cost? If you made exactly what you spent, what does that mean about your profit? That your profit is equal to 0. So there are two ways you can find the break-even point. You can either set revenue equal to cost, or you can set profit equal to 0. It's not necessary to do both, and sometimes one might not be an option. If you only have your profit function, well then how are you going to set revenue equal to cost? And if you have revenue and cost, you can either set them equal to each other or use them to find the profit function to set equal to 0, whichever you find easier. So going back to Extreme Protection Incorporated, remember what that function was. We had revenue was 60x, cost was 35x plus 6,600, and profit was 25x minus 6,600. So we can solve for the break-even point either way. We can either set revenue equal to cost. When we do that, we get 60x equals 35x plus 6,600. Now it's just a multi-step algebraic equation. Subtract 35x from both sides. 25x is equal to 6,600. Divide both sides by 25, and we get that we would need to sell 264 helmets to break even. What if you didn't want to set revenue equal to cost? What if you wanted to set profit equal to 0? Well, our profit function is 25x minus 6,600. And just solve this algebraic equation. Add 6,600, divide by 25, and you can see you still get 264 helmets in order to break even. More definitions. Now we're going to talk about this magical word called marginal. You'll see this again in business calc. Marginal cost is the additional amount of money it will cost to produce one more unit. So as you're making your product, your marginal cost is going to tell you how much it will be to make one more. What the marginal cost is, it's just the slope of the cost function. Your marginal revenue is the additional amount of revenue you make from selling one more unit. And you can find that it's the slope of the revenue function. And your marginal profit is the additional amount of money made from producing and selling one more unit. And that's the slope of the profit function. So for example, going back to Extreme Protection Incorporated, what is the marginal profit? Remember, marginal profit is the slope of the profit function. The profit function, P of x, was linear. P of x was equal to 25x minus 6,600. What's the slope of that equation? 25. So the marginal profit is 25. Well, what does that mean? That means that the profit will increase by $25 for every additional helmet that you sell. So let's look at this situation. T-Shirts Anonymous sells sports t-shirts at national sporting events. Suppose the profit function is the sale of X t-shirts is linear, which means it's a Y equals MX plus B, and that the marginal profit is $5. If the profit was $200 from selling 125 t-shirts, find the profit function. Knowing that the marginal profit is the slope, we can set this up instead of Y equals MX plus B in function form. It would be P of X equals MP for marginal profit, X plus B. Well, the marginal profit is $5, so that means that the slope of this line is 5. Well, we know that the profit is 200 when the amount that we sell is 125, so we can plug those values in for P of X and solve for B. And when we do, we get negative 425 is equal to B. So what is our total profit equation? P of X equals 5X minus 425. Couple last definitions. The law of demand. This states that the quantity demanded will decrease when the price increases. So think about it this way. If you wanted to go buy an iPad, if they jack the price up to like $8,000 for an iPad, you're probably not going to buy it. However, if they lower it to like $20, well then lots of people are going to want it. So the law of demand says as price goes up, demand goes down. As price goes down, demand goes up. The law of supply states that the quantity supplied will increase as price increases. Well, if you jack the price up of your product, less people want to buy it, so now you have more in supply. If you lower the price, more people want to buy it, so now you have less in supply. Now there's this magical thing that happens in this perfect world when your supply is exactly equal to your demand, and that's called market equilibrium. So we'll end with one example. An outlet chain has found that a particular brand of stereo, the monthly demand is $240 when the price is $900. But when they drop the price to $850, the monthly demand is $315. Assuming that the demand function is linear, let's find the demand equation. We'll let P represent the price and Q represent the quantity. So reading into this paragraph, into this word problem, we can get two ordered pairs. The quantity, comma, price. 240 stereos when the price was $900, 315 stereos when the price was $850. So all we're doing is finding the equation of the line that passes through those 2 points. First, we'll find the slope, the p from your second point minus the p from your first point over the x from your second point minus the x from your first point, or I'm sorry, q. So that gives us negative 50 over 75, which reduces to negative 2/3. So now we have a slope and 2 points. Well, the equation of our line, p equals mq plus b, we'll pick a point in our slope. So I picked that first point. P was 900, m is negative 2/3, q is 240. We'll solve for b. Negative 2/3 times 240 is negative 160. Add that to both sides, and we get b is equal to 1060. So our demand equation, P equals negative 2/3 Q plus 1060. Now, if we were asked to find the supply equation, the process would be exactly the same. The difference between demand and supply is that in general, demand equation should have a negative slope, supply equation should have a positive slope. But you would set up your ordered pairs the same way, Q comma P, find the slope between the 2 points, and then find your line. Okay, well, we'll get some more practice doing these definitions and some more applications of functions in business and economics the next time I see you.